Okay. Good morning, everybody, and thank you for the invitation. Sorry, I skipped the Eclipse introduction due to a traffic jam. Coming from Lyon was not a good idea this morning, it seems. So I will take this time to present you Iot Lab. So Iot Lab is a experimental platform, large-scale open experimental platform. So I want to emphasize basically on the open feature of Iot Lab and try to see what we can do with Eclipse. So Iot Lab is a project funded by the French government in the Initiative d'Excellence. It's an EQIPEX for national equipment. And so the consortium is with UPMC, Université de Strasbourg, CNRS, Institut Mines Télécom, and INRIA. So I'm going to go fast on the IoT. I will just show you 3 or 4 slides on the story of IoT in order to emphasize some point. And then I will present the testbed and show you basically 2 demos, so 2 videos of demos. I think is better than a long talk. So I'm sure that everybody knows this curve. I don't really care. Basically, I draw it using Excel. So it's just the source Cisco, but you can draw the curve you want. The important thing for me is just this, that basically the number of connected objects much larger now than the number of people, and then is continuing to grow. So I'm not sure it's going to be this kind of curve. Maybe we can reach a plateau, but whatever. Okay, we have 7 billion of connected objects. So even if the plateau is at 40 millions and we never reach 50 millions, it's not a big deal. At the top is just the number of IPv6 addresses you may use. So we have some space, you have some room to fit. The fact that everybody knows is that we are totally instrumented. So every object, an object is very general. I mean, it could be your smartphone, it could be a very small device, it could be your glasses if you want to wear Google glasses, it could be your watch if you want to have this kind of object. But basically, any new object that are kind of IoT object, an electronic object, can bring some computer power, some communication power, and memory facilities. So we are instrumented, and you can see that your car is an object. Okay, your car could be an object in the IoT world. And the first reason is basically how Google traffic is working. Why Google traffic is more efficient, much more efficient, and I should have a look at Google traffic this morning, than public services. I mean, Google traffic gives you more details on the traffic jam that you can have on Bison Futé for French people, for example, on their website. Just because cars are instrumented. I mean, people are having smartphones in cars and using cars, they're instruments. So they can instrument the traffic just by analyzing data. So don't even think that we are just talking about sensors, small sensors, or small objects. IoT is going to be a world of a very instrumented world. And we have also this project from it's in Cambridge, US, so Boston. So where they were using cars, so just using three-axis accelerometers in cars, so the use of your smartphone, then you can try to locate potholes. Okay, so instead of dedicating people to look at the status of the road, you're just gathering data, and you can have a very, very clear idea of the status of your road, of your traffic. Okay, that's basically the same thing. And the application is quite simple. So I don't think it's trivial, but it's quite simple. Okay, you just use the accelerometer that we all have in a smartphone in order to help your city, to help your community, to improve the road conditions. So we are all instrumented. Every object is interconnected. So whatever the numbers, and they are more intelligent, meaning that they have computing power. So if you are instrumented, connected, and intelligent, that's just a new area. Okay, that's just a shift in the paradigm. So that's basically the first message. And then you can work on your favorite domain. So you can focus on the green IoT, or you can focus basically on the fact that it's really, really dynamic. So you need a new software in order to manage the dynamicity. Just one more slide on the evolution. So I'm not a Cisco, I'm not employed by Cisco, but I do like these slides just to see the trends, okay? So once more, it's not just the numbers, but basically it's the evolution from in the fall last year, okay? It was until 4 last year, to be sure. I'm not sure of the years. Yeah, between 2012 to 2014. So basically, even in 3 years. So in 3 years, you can see the number of connection of M2M connections. Okay, so it just quite double. The number of sensor chips. So basically, since every smartphone have 3 to 4 or 5 sensors in it, you're following the trends. The IP traffic, which is very interesting, and I'm sure you're aware of this, is basically the number of standards bodies. Okay, so 227 in 3 years, that's something. Okay, in terms of standards bodies, maybe it's too much. Okay, and maybe all these standards are not going to survive. So now we have IETF, you have HC that's working on, you have OMA that's working on. Everybody is trying to push this standard. That's for sure. So maybe some of them are going to die. That's the life. But as a researcher, as people working from Eclipse, we need to follow the standards, and we need to help people using the standards. Okay, so that's a very interesting. Whatever the number of companies, you can, in terms of, so from my point of view, if I take my hat from universities, that's a big market, and we need to be prepared to have ready on the market engineers ready to work on IoT domain. Okay, and that's okay. We need also to push the education point of view. Okay, you have the investment and acquisition and blah blah, and revenue at the end. So that's not for sure. The big message is that in all domains, basically, you have a clear acceleration on the IoT domain. Okay, so the first takeaway, so IoT is here, no matter. There's no question about is it going to happen. IoT is here, is right here, and is already big. Okay, it's already a big market. It's already a big challenge in terms of education. It's already big in every domain, and it's accelerating. Meaning that it's not just a small market that begins. It's a huge market that is really accelerating. So there's a really need to improve the time to market, if I can use this expression. So we need to develop fast application and services, and it should be developed in a circular way and an opportunistic way. And basically, this is a huge opportunity. We can list all domains. Okay, basically all domains are just because objects are going to be connected, instrumented, and have some intelligence in it. So all domains is moving to the IoT or the M2M. We can discuss, but it is different between IoT and M2M later. But we can spot a domain and say, okay, if my object is connected, then if I just open a parenthesis, just a remark. So 2 years ago, so basically the e-cigarettes. Do not want to promote cigarette, but it's just an example. E-cigarette is quite a very new object. I don't know when exactly it happened on the market, but maybe 3 years ago. And 6 months after the beginning of e-cigarettes, which was invented by the Chinese people, I think, there were e-cigarette connected. Okay, so 6 months after the apparition of this kind of new gadget, I will say, widget, there was already a version of e-cigarette that is connected, meaning that you can interconnect with your e-cigarette with your smartphone in order to have the number of cigarettes you smoke, or the cigarette that you don't smoke, in fact, and what is the good thing for you. So I don't want to promote that it's a good thing to smoke, even e-cigarette, but the trend is here. Every object is going to be connected, even the dummies and seed object like a cigarette. So in order to deploy application, so Benjamin showed you some board before. I take some picture from a local startup company here, so ICOP, so they are based on M3, ARM M3. So okay, so the application is going the cycle of application is going to be the same. Basically, you're going to specify design. Maybe you're going to go through simulation, but we all know that simulation is not enough when we are talking about wireless communication. And then you want to deploy and experiment your application. That's the way. Only thing different with IoT is that the applications are distributed and largely distributed. And this is basically large scale. You're targeting large scale dissemination. So the phase of deployment and experimentation is quite a nightmare. I mean, if you want to play with 10 nodes on your desk, it's okay. I mean, you have a lot of manipulations. But then if you want to play with 100, you can try to make a PhD. So you say, oh, you're going to have a huge PhD subject, and your job is going to be experiment. Okay, the guy is going to do it 1 month. He's going to do 1, 2 experiments. And he said, no, no more. Okay, no more, because it's just a nightmare to spend your time in manual handling. It's too time consuming, and at the end it's boring. I mean, if you want to just modify 1 parameter in your application to manipulate 100 nodes, it's just boring at the end. Okay, so I think that it's our duty to provide tools. I mean, we are scientific, so we need tools. I mean, physicians that magnificent tools at CERN, for example, when they want to study a small particle, we need tools to study distributed application at large scale. That's just simple as this. And we need some large tool, meaning with IoT, we don't need just 10 nodes in a corner. We need a huge one. And we need to target, as since we are scientific, so able to make experiment on it. That's the first thing. And we should emphasize on a huge point, which is try to do reproducible experiment. I think it's very important, and that's a real challenge. Now, I mean, in computer science, we are scientific, but I'm not sure that everybody can define what is an experiment, as biologists can do, for example, and I'm not sure that we are all in the good side in order to have a reproducible experiment. So now, try to define Iot Lab. I want to present you Iot Lab. What is it? Where is it? And why? So why? I do believe that you understand why we need this kind of tool and basically how to use it. And the message is just use it. So we target, so the Iot Lab objectives, so we target M2M application, basically IoT. We want to have a kind of heterogeneity in the application that we want. And the tool should provide and to help you in order to design, to test, to deploy, and to monitor your application. Okay, so you should be able to do the right cycle on this. And already, so we will see, we have several types of nodes, so we can have this kind of home gateway scenario when a home gateway is monitoring a lot of sensor at home. So that's the first case. People are using Iot Lab in order to deploy cloud services, so the kind of 3-tier architecture when you have your sensor, the gateway, and the cloud. And we should be able to have all together, so to deploy an experiment when we have cloud services in the internet that gather data not coming from several gateways that already gather data coming from sensors. In this kind of scenario, we should be able to be IPv6 or at least IP end-to-end. So we should be able to target a specific node and use end-to-end communications. And we also provide mobile nodes because a lot of application and a lot of scenario implies to have mobile nodes. So we will see that we have more than 100 mobile nodes in Iot Lab. So right now, it's more than 2,700 wireless nodes. So we will see that we have 3 kinds of nodes. Basically, they are all in IMS band. So we have 802.15.4 and also so in two bands, 800 and 2.5 gigahertz. We clearly target low power and loosely networks. So this is basically small nodes, even if we have higher capable nodes in it. Most important is that it's totally remote access. So you can, from everywhere in the world, design an application and deploy your application on Iot Lab. You don't need to come to Grenoble in order to do it. So the sites is Rennes, Rocancourt, Paris, Lille, Strasbourg, and Grenoble. Okay, so we are in 6 sites. And Iot Lab, so the new generation, is Lille, Paris, Rocancourt, Strasbourg, and Grenoble. And the NOC is the Network Operation Center that able to manage the global platform. And we'll see why. So we have low power and loosely networks, so small nodes. We'll see the kind of node. Totally remote access. It's totally open. And we'll see what does it mean what I mean by open. And we have mobile nodes. So here, basically, you have a picture of Strasbourg. So Strasbourg, you'll see it's kind of 3D cubes, with high density of nodes. In Grenoble, we put nodes on the roof and on the floor. So basically instrument for those people that know the in-area center. We instrument 2 corridors, like a H, in fact, at our building. So all the floor and all the roof, the ceiling. That's another picture of Strasbourg. So here you have this kind of cube, and on the floor we have a fleet of robots. So you have 40 robots that are also equipped with the nodes. So you can pilot the nodes below the sensor, and they can interact with the sensor. So you can do application you want. In Rocancourt, in the picture, what you see is just a GPS, a repeater GPS. So we have a GPS, indoor GPS. So we are able to have a precise clock signal on each node. So we can, if you want to measure the time of your packet on fly, you can do it at the precision of the GPS. So that's and last but not least, in Lille, so we have also nodes on the ceiling, and you have also a fleet of robots in Lille. We have a few robots in Grenoble, but the major fleet of robots are in Strasbourg and Lille. So what are the basic commandments from Iot Lab, which is the requirement at the beginning? So first one is remote access. Okay, that's the minimum condition of a tool for scientific usage, is that you should be able to access remotely. Okay, and so Iot Lab is totally accessible remotely. You open an account on Iot Lab and you can access all the nodes, and you can book, and you can flash whatever you want on all the nodes. Then you have a direct access to debugger. So even remotely, so when you have a node, you can use GDB and do step-by-step on your application remotely. Okay, and that's also that's a lesson from the past. In the first generation, we provided a simulator, a precise simulator, in order to deploy the application and to test and debug. And then people were flashing the application on a real node. There was still a gap between the simulation, even if it was very precise, and real hardware. So right now, we are providing a GDB, a remotely GDB. So you do a step-by-step on a remote node. On each node, you have the serial port of your microcontroller. So all serial port, you can access all serial port, meaning that you can gather data. So nodes can communicate wirelessly, by wireless, of course, but you can configure basically each node as a sink and using the serial port in order to connect them to your application. So basically, you can say, this sensor is connected to a huge PC, and this PC is going to gather all application. Meaning that you can gather up, and we provide some aggregator services in order to gather application. And each node could be on internet. Basically, you can connect one node through the serial port to the internet, so it can play the role as gateway. And we'll see that we have 2 different types of nodes. So some nodes are very efficient and more powerful, and they can play the role of gateway. So that's the first thing. in terms of application, you want to be able to monitor your application, and basically it means that you don't have to modify your application. So you should be able to monitor your application without modifying your application, meaning that you're going to flash the application, and then you can, for example, monitor the power consumption. You can do packet sniffer, and you have this kind of precise synchronization in GPS, so meaning you can measure the time of a packet on the air without any modification in the application. So I don't want to do a printf in my application saying I'm going to send a packet. Okay, because if I'm inserting a printf, I'm going to change the scheduling, I'm going to change all my application, and if I want to test precise mic layer application, I don't want to do printf in my application, okay? So I don't want to squeeze totally the time precision. So we provide external monitoring without any modification. And last but not least, we are also providing a specific support of OSs, which is very important. I mean, the lesson, once more, the lesson from the past. I remember when people were pushing HPC in the lab, so we, at Flip in Lyon, we received this huge machine for the time, so 20 years ago, with maybe 200 nodes, which was huge. And we are unable to do a printf on a node. It was not supported by the OS. Okay, it was a nightmare. So the first thing we had to do is to develop an OS of this huge machine, some millions or billions of francs. It was, but that was a lesson for the past. Okay, you can have a very, very good hardware if there was no OS to support the hardware. Yeah, this hardware is bullshit and is useless. So we are totally aware of it. So we need to support OS. We have tutorials online in order to use Iot Lab, and we also support some initiative like OpenWSN. So we have this fleet of robots, so basically 100 robots. So this is Strasbourg, Lille, and Grenoble. And we also provide some free open slots, meaning that if you do have a specific hardware, so you need to come to Grenoble or Lille, but you can plug your hardware and still benefit from all the back end of the application. So you can still flash your hardware, maybe debug it if it's GDB enabled, still monitor the consumption through the USB port, but you can plug your own hardware, meaning that you can test your own hardware. Last but not least, when I said no constraint at all, is that on each node, you can flash what you want. Okay, you can use Riot OS, you can use while true and do your own OS, you can use whatever you want. Any kind of language, you do what you want on the node. You can flash a buggy code, you can crash the node, it's not a problem. Okay, the application, the platform is here to recover. Okay, so what kind of node do we provide? So basically we have, so old generation, one WSN 430. The new generation, which is for me quite comparable in terms of computation, is M3 nodes, and we have more powerful nodes, A8 nodes. Okay, so basically here it's still embedded object. Here basically you are running Linux, so it's more like a gateway, and you can play between a powerful node, gateway nodes, managing small nodes. Why? So why are you able to flash whatever you want in even a buggy code? Is because basically you have the open node. So the open node is your node. When you book your node, is the same as on the desk with a link in order to flash your firmware on it. And you do whatever you want on this node. And IoT is basically a gateway. Iot Lab is basically a gateway and a control node. So here you cannot push some code. You are only able to push code on your open nodes. Okay, so that's guarantee that we are still able to have the end of every node and flash it and reboot it and etc. If you want to look at it more closely, so basically that's the open node. So for example, the M3, and you see that on the closed node, on the gateway, we have the gateway and the control node, and the control node is the same as it. Okay, so what is important here? So this node could be get power by the external power or on a battery. So basically you are also able to say, my node is running on a battery, so I can monitor the power consumption of the battery and see how long the battery is going to live, etc. And last but not least, I want to emphasize on the fact that, so you have a kind of sensor attached to the nodes. So for example, accelerometer, pressure, luminosity. And from the control node, you are also able, so it's not clear on this, but to replay, so to inject stimuli on your node. So when I said that you should be able to do a reproducible experiment, so you can, let's say we want to test an application that just report alarms, okay? And what you want is, if I change the MAC layer, is it more efficient or not in terms of energy, for example, okay? So if you change the MAC layer, you don't want to change the stimuli, okay? Just one parameter at a time in an experiment. So what you can do is to record 1 day of stimuli, of external condition, okay? For example, I don't know, accelerometer, for example, and you can replay by the control node on your open node this stimuli, meaning that the application is not going to change. You're not going to change your application at all. You're just going to replay the stimuli that the node receives normally, okay? So you just change the MAC layer if you want to change something, but you don't change the application. You don't have to say, okay, in fact, I'm going to inject myself in the application, the stimuli. In terms of software, okay, so we support the hardware on the nodes. We support the driver, so we offer the driver, and we support libraries, communication library, for example, and operating system. Everything we are doing on this side is totally open. It's a Cecil license. I know you guys know more than me on that. And in terms of OS, so we were supporting RTOS, Contiki, and TinyOS. So that's TinyOS is just dead now, I think. And the new coming on the arena is, of course, Riot OS, which is fully supporting on the WSN and M3 nodes. And also, we are supporting open the WSN. This is a stack from 60, from Ripple, and so on. So it's totally complete stack of communication for M2M devices. And on A8 node, sorry, we are supporting Linux. So I don't know for the rest, but basically we should support also an IoT Eclipse. And Iot Lab should be a platform where you guys play with Eclipse on it. Okay, I see that there are several stacks that we are not supporting at the moment, and we should push in this direction. Iot Lab is part of a global consortium. I'm going to skip it fast. The only thing that you have to keep in mind is that basically FIT is part of One Lab. So One Lab is a federation of platforms. So when I said at the beginning that we can do some scenario when you have cloud services and then play with sensors, so we are using One Lab, okay? So we are reserving some slice in One Lab, some PC on the cloud, and so you can deploy your application on slice in One Lab, and from this slice on One Lab, you can, for example, gather data that are coming from Iot Lab, okay? So you can play at large scale on the internet. The benefits of One Lab is that instead of having everyone owning his own platforms, okay, and you are totally enabled when you are registered on a platform to get resources in another platform, you're totally enabled when you have the tools on the platform to using this tool on another platform. So the benefits of One Lab is just that, as in a IP philosophy, we define what is the common API in order that every user registered to One Lab can access every resources in another platform. And basically, so you can access Iot Lab, you can access Planet Lab, and you can access Nitos. Okay, Nitos is a Wi-Fi testbed, Planet Lab is Internet testbed, and Iot Lab is a M2M IoT testbed. How long? 5 minutes? 5 minutes? Okay. So, in 5 minutes. So how to run an experiment? So you need to book some nodes, configure your experimentation, launch your experiments. So the system is going to do it for you, and then you can monitor and get results. Okay, so maybe in a few slides. So your first thing is open an account, either on IoT Lab or on One Lab. Okay, you can choose. Then you can reserve some resources, some specific nodes. So basically, you can say I want 100 nodes, or I want specific nodes on a given site, on a given technology. So you can then you have to deploy your application. I mean, you have to write the firmware and compile the firmware, and then you need to associate the firmware with the nodes that you have reserved, and then the system is going to launch the experiment and flash all the firmware on the given nodes. And then you can monitor your application, the current, you can monitor the packet. And of course, so you can do everything from a web server, or you can use a REST API using tools, online tools. So you can, when your experiment is running, you can monitor your application on time, in a real time. And you can gather all the data you have. So if you ask for current monitoring, for example, then you are going to store all the result of your application. So let's see. A small video. So that's just to show you the experiment in Grenoble, so where the nodes are located, so on the floor or in the ceiling, in two alleys. So that's the representation where the nodes are. So you have these two huge corridors and the edge in the middle plus the small corridor. So that's the topology for you. And here, for example, is just a small experiment where we send one packet from one node and we get the signal, where the signal is received and the quality of the signal and the nodes you have. I should be able to. Okay, I fumble. Sorry. I want to advance fast. I'm not sure if I'm. Okay. Here. And here, so in this example, so we reserve all the nodes in the corridor, and we want to test REPL, okay? So REPL is a protocol that basically is going to build a spanning tree. So first thing, we launch on the top. And on the top, basically, so it should be the blue nodes that you should be able to see here. And then we add all the nodes at the bottom. And in red, we have also a packet sniffer node. So we just use this node as a packet sniffer. So here you can use your favorite Shark interface in order to get to the IPv6 packet that are on the fly. So we launch on the bottom. So we have all these nodes appearing, but they are unable. And when we connect in the edge, we add 4 more nodes. Then packets are going to flow from one corridor to another one. And here you can see that the REPL is working and blah, blah. Okay? So what is important here is basically you have some graphical interface where we can grab the nodes, select the nodes, and associate the firmware. So even in real time, you can modify your application and use it with a graphical interface. The packet sniffer allows you to use Shark, so basically whatever you want in order to have a monitoring of the consumptions of the packet. And from serial port, because here what we did is that we gather all the serial port in order to just have a feedback of the applications. We can just monitor the nodes and get their routing table so we can monitor them in real time. So I'm going to skip two other demonstrations, so just in the picture. So here, this is Strasbourg. So you have the logical view, and this is the real view. And you have the robots that are able to move below. So in conclusions, I'm going to and here you can go on our IoT Lab website if you want to see more demos and more videos. At the moment, so we have basically 400, I think now, user register. Half of them are active. Okay, so basically 200 people are running experiment on IoT. They are coming from basically all around the world, 45 countries, and it's more than 11,000 experiment launched. So some experiments are our parts, some are for external, and of course the 200 users that are active are not users from the consortium. Okay, this is external users. So we already support IPv6. It's going to be enhanced in the future, meaning that it's going to be totally open. So once you have reserved a slice in a Planet Lab, you can ping every node you want if you have a slice and nodes. Okay, at the moment when you have your node, you still need to set up a tunnel, but you have a tutorial on it. At the moment, the robots are predefined trajectory. We really want users to be able to play with robots and define their own trajectories. It could be fun. It's a little too late. There's a lot of calls on H2020 on IoT. I know that most of you are writing a proposal right now. It's going to end in the middle of April, I think. And I already know that a lot of proposals are going to use IoT as a testbed. So the message is just use it. Okay. Do not hesitate to send us your feedback of what is more important for you. I already target that we should support higher level libraries. Not only we are not totally connected to OMA, and should be connected to OMA. That's a huge collaborative work. So a lot of people are working or were working on it. And if you want to access, so it's iotlab.info for it. And then you have so that's the main site, and we have the wiki and the source site on GitHub. And if you want to know more, so we have one lab, which is the Federation of Platform, working on it. And so I mentioned ICOB, so the startup, because it's come from INRIA. It was a partner of my group. And basically because all the hardware deployed in IoT is co-designed with ICOB. So if you people want to already deploy a small IoT in your lab, IoT Lab, a copy of IoT Lab is running in France Télé Orange RTD and in Taiwan. So people are using the back end of IoT in order to run their own experiments and platforms. Thank you.
Any question? Yes?
I just have one small question about that project and the difference with the SenseLab project.
So SenseLab project was the WSN 430.
Yeah.
So basically SenseLab now is just part of IoT Lab.
Okay.
It's completely integrated.
Other question? Yes?
Is the entire architecture of the IoT Lab open? Like, is it reproducible in smaller scales personally, or?
So all the files describing the architecture is open. So what they did in Taiwan, they basically copy part of IoT Lab with 25 nodes at the moment. So they have a small architectures, standalone at the moment, but they want to connect it to one lab, so they want to be part of the federation. So you can copy it. Okay, we are working in order to make it very modules for the backend. So that's if you want, yeah, you can.
Thank you.